Okay, now we move to the part on arithmetic sequences where we are asked to write a function for the sequence, which is just, if you're asked to write a function, you're basically being asked to write an equation. So I want an equation that produces this sequence. So ultimately, what I'm looking for at the end, I'm looking for something that says a sub n equals, and I'm going to need in my right side of the equation an algebraic expression where I can input a value of n, which is a placement in the sequence, and the expression, whenever I substitute the value of n in, it will churn out a value of the sequence. So for instance, I want something where if I put in n is 4, if I find a sub 4, and I put the 4 in for n, it's going to churn out a value of 13. That's the goal here. Now, to get to that, how do you write that? I think it's best to investigate the sequence on a table. So I'm going to have a table n and a sub n. So my first term, my position is 1. My first term of the sequence is 4. For my second term, the position is 2, and the value of the sequence is 7. For the third position, where n is 3, that's your third term, the sequence is 10. For fourth position, it's 13, and 5 would be 16. So, I think we can see, again, because this is arithmetic, that we are constantly adding 3. Now my goal is to expose that addition of 3. So here's what I have. The first term is just straight up, it's 4. That 7 is found by doing what to the 4? Adding 3. So this 7, we can think of it as 4 plus 3. Now we're seeing that added 3. This third term is the previous term, the 7, where you add on a 3. Now, the 7 has been written as 4 plus 3 in the previous position, right? So that 4 plus 3, there's your 7. Now, what do we do to that 7? We add on another 3 to get that 10. So there's our 7, we add on another 3. And now this 13 is the 10 plus another 3. Now, the way we wrote 10 previously is 4 plus 3 plus 3. So here I'm going to write a 10, 4 plus 3 plus 3. And now to expose how I get the 13, to that 10, I'm going to add on another 3. Now, I think you could probably realize a pattern that's going on here. So if I wanted the fifth term, which we know is 16, you probably notice, hey, it's going to have a 4 plus something, right? This has 4 plus nothing, right? 4 plus 0, but 4 plus something. And in essence, we're adding on a bunch of 3s. Here we see 1 3, here we see 2 3s, here we see 3 3s. So you're right, we're going to see 4 3s. And yes, that's your 13 plus another 3, there's your 16. So if we look at the nature of this pattern that's been established, I think we can figure out how to find what the 10th term is going to be. Now my board is pretty small, so I don't want to write out a bunch of addition of 3s. So I'm going to ask you to think back to what can you do to express constant addition of 3 in a more simplified way. Well, I don't know what this 10th term is, right? I could work it out. I'm not going to, because I'm going to use the pattern. Well, how many 3s are going to be added? That's part of what we have to figure out. So let's look back and see if we can figure this out. For the fourth term, there were 3 3s added. For the third term, there were 2 3s. For the second term, there was 1 3. And for the first term, there were no 3s. So for the 10th term, how many 3s do you think we're going to add? You're right, we're going to add 9. Sorry, my dishwasher is finished, and that's beeping to let me know it's done. So we're going to add 9 3s, which I don't want to add 9 3s. Like I said, I don't have enough room for that. So the quick way to show repeated addition of 3 9 times is to take 3 times 9. Likewise, this could be expressed as 4 plus 3 times 3. This could be expressed as 4 plus 3 times 2. This is 4 plus 3 times 1. This could be written as 4 plus 3 times 0. Does that make sense? And if you notice, the number of 3's you're adding, which we're now changing to multiplication, is exactly what? It's exactly what? 1 less. It's exactly 1 less. So, if I wanted to know what would the 50th term be of this sequence, I don't want to work it out. I could work it out. I don't want to. I hope you don't either. You realize what the foundation for all of these is it starts with a 4 and you add on a 3 1 less amount of times than the position. So 4 plus 3 times 49. You would do 3 times 49, add on the 4, boom, you'd have your 50th term. So, how do we go about finding any term for this sequence? So, what if I want what it is for any term? Well, let's not discount everything that's taking place. Every single one of them has 4 plus, 4 plus, 4 plus, 4 plus. So this, the nth term of that sequence, has 4 plus 3 times, right? They all have plus 3 times, plus 3 times, plus 3 times. And we know it's 1 less than the term. So you have to think, what's 1 less than n? 1 less than n. You're right, 1 less than n is n minus 1. So what this is saying now is the nth term of the sequence, the nth term, a sub n, is going to be 4 plus 3 times n minus 1. Now watch, let's put that to use. I'm going to get rid of this table, and I want you to see that this formula that we just wrote produces all of these terms. So if I want to see, does it work for the second term? That means I'm finding a sub 2. So that 2 tells us n is 2. So in for n, we are going to put 2. So we will have 4 plus 3 times 2 minus 1. Let's do the math. 2 minus 1 is 1. 3 times 1 is 3. So we get 4 plus 3, which is 7. A sub 2 is 7. Doesn't that say the second term is 7? Let's see if we get 13 for the fourth term. A sub 4. A sub 4 tells us n is 4. So in this sequence, we're going to let n be 4. So we'll have 4 plus 3 times 4 minus 1. 4 minus 1 is 3. 3 times 3 is 9. 4 plus 9 is 13. So this is telling us a sub 4 is 13, which we're not shocked by. We knew it was that. And that's basically how you look at what's behind writing the formula for the sequence. Now, do you have to build a table every time? Absolutely not. That would be absurd. There is an easier way to look at this. Let's look at this sequence and look at how it relates to this formula. What is 4 in that sequence? It's the first term, which we write as a sub 1. That's how we write the first term. And look, right there, there's our 4. So a sub n is the first term. Do you see? A sub n is the first term. I didn't say a sub 1, I said first term. First term is 4. Plus 3. What is the plus 3? How do we get from one to the next? We constantly add 3. If you take any term minus its previous term, a new term minus the old term, you'll get the constant difference. The constant difference of this sequence is 3. So, what does this say? The first term plus 3. 3 is our constant difference. And then multiply it by n minus 1. This right here, this is the general form for the function for any arithmetic sequence. A sub n is the first term plus the constant difference times n minus 1. There it is. So, if we wanted to put that to work for us for some random sequence, let's make one up. Let's start with 8, and let's say we've got 13, then 18, then 23, then 28, and that sequence goes on. And I'm asking you, what is the function for this sequence a sub n? If I say that sequence is that, I want the rule for the function. What is a sub 1? It's just whatever the first term is. So let's look at our sequence. What's the first term? The first term is 8. This is our a sub 1. We need the difference. What's the difference? How do we get from one term to the next? What's a new term minus an old term? A new term minus an old term. A new term minus an old term. You can see the constant difference is 5. So if I wanted the rule for this sequence, I just say a sub n is the first term, which we know is 8, plus the constant difference, which is 5, and we multiply it by n minus 1. That will generate this sequence. If you want to check to see will it make just some random term, let's see if we can make that one. That is the 1, 2, 3, the third term. The third term we know n is 3. So a sub 3 would be 8 plus 5 times 3 minus 1. What's 3 minus 1? 2. 2 times 5, 10. 10 plus 8, 18. The third term is 18. What's nice is when you have this formula, if I ask you a question, what is the 101st term? I want to know what's the 101st term of this sequence. You have this formula, the 101st term, a sub 101, is really not that big of a deal to find because you know n is 101. Sorry about that weird pause. 101 minus 1 is 100. 100 times 5 is 500. 500 plus 8, 508. There you have it.